In today's video, we're pairing the Ryzen 9 5900X with the GIGABYTE X570S Aorus Master motherboard. The X570S Aorus Master is the slightly improved version of the X570 Aorus Master. It has an embedded controller, which makes it one of the 4GB motherboards to support Active OC Tuner. AOCT is GIGABYTE's very clever way of addressing one of the fundamental problems with overclocking AMD Ryzen CPUs. The best single-threaded performance is delivered by Precision Boost Overdrive. However, the best multi-threaded performance is delivered by manually overclocking our CPU. So effectively, we have to compromise. Do we want to have the best single-threaded performance, or do we want to have the best multi-threaded performance? Active OC Tuner solves this problem. It allows us to actively switch at runtime between PBO and manual overclock. So effectively, it gives us the best of both worlds. Also great is that Active OC Tuner doesn't actually take that much additional configuration work. Think about AOCT as follows. It is exactly like Precision Boost Overdrive, but the lowest frequency is manually set by us. So we need to know two things. One, what is the lowest frequency we will allow? And two, at which point do we want AOCT to switch between PBO and OC mode? Sadly, we cannot just set a minimum frequency and have the system switch based on that. Instead, we need to use a proxy metric, a certain current threshold or a certain temperature threshold. There's not one specific method of determining the right threshold, so I'll show you one example using Cinebench R23. Okay, for our lowest frequency, we choose our manual overclock from strategy 2B, which is an average frequency across all cores of 4,587 MHz. In the operating system, we first open hardware info. We make sure we can monitor both the effective clock frequency and the current IOUT. Then we start the Cinebench R23 multi-threaded benchmark workload and change the affinity to one core in Task Manager. Now monitor the effective clock frequency. It will be higher than our target of 4,587 MHz. Now you can gradually increase the Cinebench R23 thread count. When you reach 4,587 MHz or below, check the current IOUT reading. This value will be our input for the AOCT CPU current limit. In our case, we reached a frequency of 4,587 MHz at 5 active threads. The current varies between 42 amps and 48 amps. So to be on the safe side, we pick 46 amps as the CPU current limit. So to reiterate what's happening, AOCT will switch between OC mode and PBO when the CPU current hits 46 amps. Anything above 46 amps will engage manual OC mode. Anything below 46 amps will engage Precision Boost Overdrive. Now let's configure the system. Upon entering the BIOS, press F2 to switch to advanced mode. Set CPU ratio mode to per CCX. Set CCD0 CCX0 ratio to 46.50. Set CCD1 CCX0 ratio to 45.25. Enter the advanced CPU settings submenu. Set Active OC Tuner to enabled. Set CPU current limit to 46. Set CPU temperature limit to 100. Leave the advanced CPU settings submenu. Set Extreme Memory Profile XMP to Profile 1. Set CPU vCore to 1.35 volt. Go to the Settings menu. Enter the AMD Overclocking submenu. Set Precision Boost Overdrive to enabled. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. As we can see from the benchmark performance, we eliminate the performance loss in low-threaded benchmark applications by enabling PBO and maximize the performance gains in highly multi-threaded workloads by configuring our manual overclock. As shown, GIGABYTE's Active OC Tuner gives us the best of both worlds. Alright, let's wrap this up. The GIGABYTE Active OC Tuner is a neat little feature that addresses the biggest challenge when it comes to AMD Ryzen CPU overclocking. Namely, when you do manual overclocking, you lose the benefit of really high frequency single-threaded performance. This is only offered by Precision Boost and Precision Boost Overdrive. GIGABYTE's Active OC Tuner, if correctly configured, will force the system to switch between Precision Boost and manual overclock right at the point where the Precision Boost frequency would drop below the frequency that you set in your manual overclock. So you get the best of both worlds. You get to enjoy the really high single-threaded frequency offered by Precision Boost, and you get to enjoy the high frequency in multi-threaded benchmarks offered by your manual overclock. That's a win-win in my book. As per usual, if you have any questions, feel free to drop them in the comment section below, and until the next time.